Bolboaca and I'm coming at you from the Mozaic Works studios, and what I have for you today is a discussion about the bet that is put right now in front by the LLM enthusiasts, large language model enthusiasts. If you don't know, large language models are a part of artificial intelligence. They have come to be used interchangeably with artificial intelligence in the past years, but they are not the only way to do artificial intelligence. And LLMs result into things like ChatGPT, Google Gemini, and all these agents that you can use right now for various things, to generate images, to generate text, to have conversations, to generate videos, a little bit, and so on. And I like to talk about the bet that these people are making about LLMs and what is happening from my perspective, from my analysis, and what we might expect out of it. So briefly, what this is going to be about is that the LLM bet is that with enough data, large language models will turn into artificial general intelligence. That means an artificial intelligence that is able to solve problems that go beyond the scope of the things it was trained for, and that would bring in a lot of societal changes, because if we get to AGI, AGI can also create better AGIs, which leads into a very, very fast development of artificial intelligence, something that is impossible to control, most likely, and very, very with a lot of impact on the whole world. Imagine if an AGI is able to solve problems in science, in physics, in mathematics, but also practical problems, to bring designs, medicine, find solutions to various diseases. But on the other hand, an AGI can also be used for the wrong reasons, create diseases and viruses, create cybernetic threats that are very difficult, if not impossible, to counter, create weapons that are very difficult, if not impossible, to counter, and so on. So if we get to AGI, all bets are off. We don't exactly know what will happen then. But if we turn back to the bet of many people who are working in this domain is that if we add a lot more data to LLMs, and of course use a few other optimizations, they have some paths that they can still follow to optimize their models. With enough of this, they will get AGI. And I will argue that there are some reasons to believe that this might happen, but I also don't believe it will happen. So this is the video in a nutshell. Now let's go into it. I've seen recently a video by Sabine Hossenfelder called AI Scaling Hits All Rumors Say. And she's examining some data about AI. If you don't know Sabine Hossenfelder, I highly encourage you to follow her. She is a very good science communicator, and she communicates a lot of stuff about various experiments and things that are today very important for us. And this is where I got part of this information, and I encourage you to watch this video. I will link it in the description. But let me go back before we discuss the bet. And okay, so the bet is, we already discussed it. Let's look a little bit of the history of AI. In the 70s, we had expert systems, which are basically a long set of rules. And people believed back then, the ones who were working in the domain, that if we write enough rules, enough yes, no, true, false rules, if then rules, then we'll end up with AGI. They hit a wall because they realized there were too many rules required and that a lot of the rules revolved around a very specific understanding of things. Because one challenge with human intelligence and human language is that we can reason around concepts that are expressed by different words in the same context. So because of that, it's very hard to capture everything in rules. In the 90s, we had neural networks, and I actually studied a little bit neural networks in the university. And they were excellent at text and image recognition. We are still using them, by the way. Neural networks are in most cameras with face recognition, in text recognition. So if you have OCR systems, when you scan and transform things into text, there's probably a neural network behind it. LLMs are built on top of neural networks, but they also have additional things. But this also hits a wall. It doesn't get better, right? They work until some point, but then they don't work anymore. Oh, and by the way, some translation systems use the neural network. In the 2010s or 2000s, I'm not sure exactly, we have deep learning. That's another trend. And we hear about various agents that beat top players at chess, at Go, at StarCraft 2. It was pretty interesting for a while. It's also when we hear about adversarial learning. Basically two systems. In this case, the way these systems learned at some point, the way they learned Go, for example, or StarCraft 2, was by playing millions of matches between different versions of the AI. And based on the results, improving themselves. So part of it is learning that is unsupervised. And it happens because of this adversarial thing, where you put two AIs against each other, and because they are really fast in playing these games, they get a lot of experience very quickly, and you get systems that can be top players. But since then, we haven't heard a lot about these. They are used, definitely, in business analysis tools, in big data, and things like that. But we don't know exactly if, there's no AGI coming out of this. And then 2020s, we get LLMs. They are great at language, very bad at logic and facts. And right now the question is, did they hit a wall? So the bet is that with enough data, LLMs will turn into AGI. And the argument behind this is that LLMs have somehow uncovered some deeper patterns in the reality that they can use to become really intelligent, and that by providing even more data, they will be able to kind of dig deeper find those patterns that make them truly intelligent, and we get AGI. And let's look first at the pro arguments or reasons. The first argument is that LLMs work better than expected, and indeed, I've seen some talks with neural scientists who said that they were it was kind of funny. They were a little bit frustrated, but also happy. They were a little bit frustrated that all their research in the domain was trumped by this idea of throwing more data at the algorithm behind LLMs. Because, of course, you are a scientist, you are studying, structures and figuring out things. But then there are some people somewhere, they just decide to throw more data into an algorithm, and it gets a lot of interesting results, much better than you would have from your research. So LLMs are definitely better than expected, and anyone who has used them can see that they work impressively well, at least in terms of results. We can still discuss, and I'm going to go into the downsides in a minute. The second argument is that LLMs give original answers. And if you've used LLMs for long enough, you might have seen an answer that comes from nowhere, that you don't find on Google or. And the third one is that LLMs are convincing. When you discuss with ChatGPT and so on, it seems like there's something behind it. It seems as if there's maybe consciousness, maybe intelligence driving this thing. Okay. So these are a few arguments, and let's go through those. I'm going to start with the last two ones, And the problem that I see with this is that people tend to anthropomorphize. Our brains are adapted to find patterns, even when they aren't. And some of the patterns that we find really quickly are those related to human and animal behavior. Human and animal aspect, how they look. Okay. And one example here is optical illusions. Another example is that designers, industrial design, let's say car designers, right? But industrial designers in general, they know that if they design objects in the shape of something that resembles an animal, a human face, even if it's just suggested and not really the whole thing, this will provoke certain emotional responses. For example, if you look at sport cars, they tend to look like felines, like wild felines. If you look at the front of a sport car, the lights are placed such that they look kind of like the eyes of a, Black Panther or something like that. Why? Because they want to convey agility and speed. So these are some things that are happening automatically in our brains. This also creates, based on the same pattern, we get logical fallacies, right? Correlation is not causation. This is one of the very common logical fallacies. You see two things happening at the same time, and then you assume that one thing happening after another, and you assume that the second was caused by the first. It's a very common fallacy. Or the fallacy of future success. Past success does not predict future success, right? So if you have in this case, if LLMs are very good up to a point, it doesn't mean that they'll get better after that point. That's one of the good examples here. So these are some of the logical fallacies that you can fall into. And the reason these exist is because our brains are very trained, deeply trained to find patterns that make us run or fight. These are some of the most basic ones. And then after that, build on top of those, we have a lot of different emotions generated by these patterns. So because of this, the question is, can we trust our judgment in saying that LLMs are convincing? That's what they were trained for. So it's already there is a bias there. Why would you try to train a large language model that is not convincing? It makes no sense, right? It makes no business sense. It's just a waste of time and money. The reason why they are so convincing is because they were trained to be so convincing. And our brains fill in the blanks, see the patterns, and they say, oh, look, they are very convincing. Maybe there's something behind it. Because we don't know any intelligence or consciousness we don't know anything that resembles intelligence or consciousness that doesn't have intelligence or consciousness behind it. This is a completely new thing for our brains. So it's very easy to jump to that conclusion. How about new answers? Well, let's look a little bit on how LLMs are trained. You get the whole of the internet, almost, but let's say the whole of the internet. You get all books ever published. You get all videos ever created, and so on. And then you put those into a statistical mechanism. You basically split them into smaller things. And what LLMs do is they combine these things based on statistics in a way that is trained to be convincing and to create something that makes sense. So once you do these statistical sampling, how likely it is that occasionally you can combine things that seem like a new idea? And that's the question, right? So I have my doubts that these are actually new ideas or original thoughts. There is also a problem that we don't fully know what the training materials were. So maybe some of the ideas that seem new, you don't find them because they are in unpublished training materials. So it could be that. But also just by grouping things, eventually you end up with a combination that people haven't thought about. And perhaps this is a sampling bias, where you look at the thing that is like with the lottery, right? If you only look at the people who won the lottery, then you say, oh, I have a chance of winning the lottery. But if you see everybody who lost the lottery, you will figure out really quickly that the chances are extremely low. So yeah, sampling bias or survivor bias, maybe. Because you hear about those things that were impressive and you don't hear as much about the normal conversations or the ones that were a bit annoying. this still leaves us, and by the way, this brings us to an interesting point that LLMs, despite their results, which are quite interesting, their training process is a lot less effective than for human adults. I imagine that none of us has read the whole of the internet, all of the books ever published, watched all the videos, in order to be able to speak in a convincing manner. Right? We are able to do this with much less data, which means that our brains are still doing some optimization that we don't understand, that doesn't fit the LLM paradigm. All right, but LLMs give surprisingly good results, and let's give them that. It's definitely something that happens. So the question is, does this mean that LLMs actually uncover patterns we don't see? And this is really the bet. This is really the bet. If LLMs really uncover hidden patterns, adding more data will make them better at finding those hidden patterns, perhaps to the point of getting to AGI, although that doesn't necessarily follow. They can get just better, but not necessarily to the point of AGI. If not, they will hit a wall. So now, what's the answer to this fundamental bet? Well, we don't know, obviously. Now, I have an opinion, and I'm going to state it, and let's say if we'll have an interesting conversation about it. I believe that what happened in the AI is that the same pattern applied. Some researcher focused on the past on a part of the intelligence, rule-based, if-then things, neural networks, because something resembling how neurons act in the brain, LLMs for language, and so on. More people believe that this pattern explains intelligence and invested into it up to a point where it turned out that it didn't. And underneath this, the biggest challenge, it seems that intelligence is more than each of the things that they looked at. Intelligence is more than if-then rules. Intelligence is more than the physical neurons and how they connect with each other and trigger things. It seems to be something more, some kind of optimization, or maybe some kind of feedback mechanism. So I believe that the performance of LLMs shows the language plays a very important role in intelligence. This is something that has been theorized before in linguistics, in neural studies. One of the explanations why humans have developed so far beyond the other species is because of language. Although we know now that many species actually have language and they do communicate. But it seems that our communication goes on a higher level. So perhaps language plays an important role in intelligence. That's something that I think is reasonably true. Now, I'm not a neuroscientist. I hope they will come up with some studies about this. And if you know about any, I'd love to see them. But I think we still don't know the full picture, which means that LLMs will hit a wall eventually. They will try to optimize them. They will throw a lot of money. We'll still use LLMs because they are definitely useful for certain things. They will probably optimize parts of the LLMs, particularly the energy consumption and Um, yeah, all kinds of, the amount of data needed maybe will get better. But getting to the AGI, I don't think so. It seems that intelligence is much more than language. It seems that intelligence involves logic, which is not necessarily part of language. And I'm going to throw this in. I'm not an expert, but I think that there is a role played by a feedback mechanism akin to emotions. Emotions are very useful in regulating intelligence, I believe. And based on the psychology that I've read, it seems to be really part of it. So, yeah, that's my conclusion. I don't think we'll see AGI, at least not from LLMs. If something else comes along, then again, all bets are off. But I think LLMs will hit a wall. All right, what do you think about all this? Does this make any sense? Do you have other resources, information, knowledge that you'd like to share? Do you have any questions, comments, thoughts? Let us know in the comments. We love comments. We also love likes, shares, subscribes. Let other people know about this. And who knows, maybe we'll have more conversations, better conversations in the comment section here once we have more people watching these videos. Thank you kindly for the view. And until next time, remember to think, design, and work smart. See you next Saturday.